Hello students. In this video, we will talk about the different measures of variability. Okay. Now there are four main measures of variability that are commonly used. The first one is your range, which is the difference of your highest value and the lowest value. Your range is used, when you are dealing with numerical data to emphasize extreme values. The next measure of variability is your quartile deviation. The quartile deviation is the difference between the first and the third quartiles. This describes the central 50% of a distribution or of a data set. The next measure of variability is the one that is commonly used, which is your standard deviation. This is a measure of spread of data that is used mainly for numerical data and with respect to the mean. Now, the standard deviation is always used when the mean is used. So they come in pair, they are used in pair. The next is what you call your variance, or the square of your standard deviation. To get the range for an ungrouped data, we just have to subtract the highest value and the lowest value. Given this set of data, we identify the highest and lowest value. It is good that we arrange this in an ascending manner or descending manner so that we can easily identify the highest value and the lowest value. In this case, it is 60 minus 12. Therefore, the range of this data set is 48. The next method that we will use is your quartile deviation. The formula for your quartile deviation is Q3 minus Q1 divided by 2. To get the quartile deviation, we have to first identify the Q3, right? Which is identified using the formula 3n divided by 4, which is the 75th percentile. While the first quartile is identified as n divided by 4, which is around the 25% of the data. With this given data set, the one above here, we first identify the third quartile using this formula. We substitute the formula with the number of data in our data set, which is 7. We arrive to 5.25, or approximately the fifth data. In this set, the fifth data is 31, which gives us the quartile 3, the third quartile, as 31. On the other hand, we find the first quartile, which is n divided by 4. We substitute the data, 7 over 4. We get 1.75, or the second data in the observation. In our data set, our second data is your number 12, which gives us 12 as the quartile, the first quartile. We substitute the values that we have identified into our formula of quartile deviation. We get 31 minus 12 divided by 2, arriving to a number of, or to a quartile deviation of 9.5. To find the standard deviation for an ungrouped data, we use the same data that we have. We use the formula of the square root of the summation of x minus mean squared divided by n minus 1. So with this set of data, we try to find the mean, which is around 26.86. This is based on our last examples computation, or the last video rather. Identifying the mean, we now identify the x minus x mean, okay, or the mean. So we calculate it by finding first the difference between the value and the mean. So therefore, the first data, which is 12, we find the difference between 12 and the mean. Likewise, in the second data, which is also 12, we subtract the mean from the second data. And we get these values. After getting these values, we multiply or we square this value to find the one that we're looking for, or the value that is needed for your standard deviation. Squaring the values or the difference between the two, the data and the mean, we get these values. And after we get these values, we add them all up, and we find the summation of x minus mean squared. Now that we know the value of summation of the x minus mean squared, we will now substitute it in our formula. If we substitute it, we get 2,224.8572 divided by 7 minus 1. 7 being the number of data in our data set. By doing the calculation, we arrive at a standard deviation of 19.26. Now, the variance is the square of the standard deviation. So just square the 19.26 standard deviation, and you'll arrive to a variance of 370.95. Now, for our group data, we refer to our previous example, right? In our previous example, we identified this particular frequency distribution table. If you review the data that we have in the previous video, we already constructed this frequency distribution table. Now, to find the standard deviation of our group data, again, we look into our mean, okay? And as we have solved in our previous video, that the mean of this particular group data, we have a mean of 15.4%. Now, as we have the formula for the group data of the standard deviation, or rather the standard deviation of the group data, we use the formula, but we insert the frequency in the formula. All right? Now, to get this particular part of the formula, of the standard deviations formula, we construct two columns. All right? Two additional columns. The first is the difference between the midpoint and the mean squared. And next will be the square of the midpoint and the mean times the frequency. All right? So if we first construct this column, we get the midpoint minus the mean, and then you square it. And then we get 29.16. On the second part, or the second class, we do it the same way. We subtract 13 from 15.4, and then we square it. So that's why we get 5.76. And as well as to the other classes. After we get the square of the differences, we now multiply the frequency of that class to this. So if we multiply 29.16 by 4, we get 116.64. If we multiply 5.76 with 3, we get 17.28. If we multiply 0.36 with 8, we get 2.88. And as well as to the other classes. Now, after finding this particular part of the formula, we add them all up. And this will be part, or this will be the numerator of your standard deviation formula. Right? So substituting the formula, we get 262.8 divided by 20 because of the total number of frequency that we have is 20 minus 1. And when we do the computation, we get 3.72. Now, to get the quartile deviation in the group data, we have to do two computations. First, we have to find the third quartile of the group data. So as we have discussed in the previous video, we use this formula to find the third quartile in our group data. Now, first, we identify where is your third quartile class. We find it by using the formula 3n divided by 4. When we do the computation, it's 60 divided by 4. We arrive at 15. And when we count the 15, it actually occurs on the third class. Therefore, this class is your third quartile class. Now that we identified the third quartile class, we can now substitute it in our formula, right? So the third quartile is 14.5 plus 3 times 20 divided by 4 minus 7 divided by 8 is equal to 3. We arrive to the third quartile value of 17.5. The second computation will be determining our first quartile, and we use this formula for the first quartile. The next step will be to locate where is the first quartile class, which is we use the formula n divided by 4 is equal to 20 divided by 4 is equal to 5. Now, if we identify the first quartile class, it is located in this portion. Right? In this part. So this one contains the first quartile class. And to compute, we substitute 11.5 plus 20 over 4 minus 4 divided by 3. We get a quartile class, or the first quartile class value of 12.5. Now that we know our third quartile and our first quartile, we can now determine our quartile deviation for group data. To get our quartile deviation, we use the formula Q3 minus Q1 divided by 2. Upon getting the values, we know that our third quartile value for the group data is 17.5, while the first quartile value is 12.5. We divide it by 2, we get a quartile deviation of 2.5. That ends our lecture for this module. If you have any question, you can always send me a message anytime of the day. Thank you very much.